All right, you guys. So yesterday we started talking about scatter plots. And a couple things that we talked about with scatter plots is being able to identify whether or not they're correlated. We talked about positive correlation, negative correlation, or no correlation. We also talked about the strength of the correlation, if there was a positive or negative correlation, by being able to draw a line of best fit and then being able to make a decision of a correlation coefficient that goes with that particular correlation. So the first thing I want to be able to do in this warm-up is we're going to draw a line of best fit. After we can draw a line of best fit, based off of the way our data looks in comparison to that line of best fit, we can identify a correlation coefficient that would go with it. So the first thing I'm going to do on all three of these is I'm going to go ahead and draw a line of best fit. So in this case, I would assume that the line of best fit for this graph to be somewhere around there. If you remember correctly, the line of best fit doesn't have to go through any of our data points, particularly. We talked about the one thing I don't want you to do is to put it in between or to connect the dots from your first to last data point, but it needs to best represent all of the data points. So in this case, this line of best fit that was drawn right here doesn't necessarily have to go through as many data points, but it has to represent the data points on top as well the data points below. So yours might look a little different than mine, but in general, I think that that line of best fit would be pretty accurate. If we go to the second one, I can also draw a line of best fit, and I'm going to call it about right there. So notice in this case, we do go through your last dot, pretty much we got a couple dots that we go through, this one right here, this one right there. But once again, we're just trying to equally represent all of our data. Yours might look a little bit different than mine, but it's going to look somewhat similar. And we're going to be able to use that later today to be able to make some predictions about it. If I look at this last one, however, I'm not really sure where to best place the line of best fit. I don't know if my line should be going in the negative direction or if it should be going in the positive direction. And so in this case, since we can't make a judgment call, I'm going to call this no correlation. And that's exactly what no correlation means. It just means that we can't make a judgment call as to where to best put the line of best fit. Our data does not look as though it's correlated. So I'm going to go ahead with the no correlation, and we'll write our correlation coefficient. In this case, we're going to say that our correlation coefficient is 0. Now remember that with our correlation coefficients that we talked about yesterday, they're all going to be in between -1, 0 being no correlation, and then +1. Now, the -1 represents a perfect negative correlation, which we don't see in either of these graphs. 0 represents a no correlation, which we saw in the third graph, and a 1 represents a positive correlation that's perfect, which we, again, don't see. The first thing I'm going to do is we'll talk about this one. In this case, it's obvious that we have a negative correlation. It's negative because the slope of our line is negative. We're going down is what a lot of people say also. If I go to this one, the second problem, it has a positive correlation. Positive because we're going up. So now in order to be able to come up with a correlation coefficient, we have to be able to decide the strength of that correlation. I remember yesterday when we talked about strength, we're talking about how close are these data points to our line of best fit. The closer they are, the stronger they are, and the more so we're going to get to -1 if it's a negative correlation, or to +1 if it's a positive correlation, like in this one. We kind of talked about this like quiz grades too. If your objective was to get all of those dots, all of these little small data points on that line of best fit, what grade would you give them? Obviously, this kid doesn't get 100. He doesn't have that many data points that are close to that line. And so in that case, what I think this kid should get, based off of what I see, maybe a 60. And so we'll represent that with a 0.60. Yours might be a little bit different. You might have thought of 50, 55 or something, and then your decimal, your correlation coefficient should match that. Now, since this is a negative correlation, we're not just going to write negative 0.60. We're going to, or excuse me, positive 0.60. We'll write it as negative 0.60. And that's the only time that, whether it's negative or positive, will affect the correlation coefficient. If I look at the next one, it is positive. We've already identified that. However, notice that these dots are a lot closer than those. And so when we're identifying a correlation coefficient, we have to take that in mind. If the objective was to get the dots on the line, this person did a pretty good job. And so I would say maybe like 0.85, meaning that maybe about an 85%. In that case, since it's positive, we don't have to write a sign because the correlation coefficient's already positive. So the first one, it was a negative correlation. We drew our line of best fit, and we ended up giving it a grade or a correlation coefficient of negative 0.60. Second one, 0.85, because it was a lot closer to the line. Our dots were a lot closer to our line of best fit, and it's positive correlation because it's going up. And then the last one, we couldn't draw a line of best fit, so we called it no correlation, and then it had an R value or a correlation coefficient of 0. So we're going to go ahead and continue on with that process with what we do today, but this is just our basics with lines of best fit, correlations, and correlation coefficients.